All right, so last time we introduced matrices and we saw how we can use the augmented matrix of a system of linear equation, how to use that to solve the system. And we did either row echelon form and then Gaussian elimination to find the solution, or we did the reduced row echelon form and then we found Gaussian Jordan elimination to solve the system. Today we're going to solve a system of linear equations by using inverse matrices. So first we gotta decide what is an inverse. So a square matrix, remember from last time that a matrix had a number of rows and a number of columns. So a square matrix, it means it has the same number of rows and columns. So for example, it could be 2 by 2 or 4 by 4 and stuff like that. So 4 rows and 4 columns, 2 rows and 2 columns. So only square matrices can have inverses. So square matrix A has an inverse if there exists another matrix B of the same size, such that when I multiply A times B, I get another matrix which is called the identity matrix. And if I multiply B times A, I get the identity matrix again. So the identity matrix is just a matrix that has ones on the diagonal. Matrix. Ones on the diagonal. And zeros everywhere else. So for example, the identity matrix with 2 rows and 2 columns, we denote it with I2, and it's just going to have ones on the diagonal and 0 everywhere else. Or the identity matrix with 3 rows and 3 columns is going to have ones on the diagonal and then 0 everywhere else. So what is so special about this identity matrix? If I have a matrix A, for example, 2, 3, 0, 1, and if I multiply it by the identity matrix of size 2, so I2, let's see what we get. So A times I2 is going to be 2 times 3, 0, 1, and then this is for A and I2. 1, 0, 0, 1. Let's multiply this. Recall from last time, they're both 2 by 2. So the result is also going to be a 2 by 2. And how do I multiply? I'm going to do 2 times this plus this times this. So I take the first row, multiply by the first column, and that goes in here. So 2 times 3 is 2 plus 3 times 0, so that's just 2. Then I take the first row, 2 times 0 is 0 plus 3 times 1, that's 3. And then I look at the second row and multiply by the first column. 0 times 1 is 0, plus 1 times 0 is 0. And then 0 times 0 is 0, plus 1 times 1 is 1. So what do you notice? What did I get out? I got out A. So the identity matrix plays the role of 1 for the real number. So if I have 2 times 1, that's 2. If I have x times 1, that's x. So multiplying by the identity matrix does not do anything for the matrix. All right, so let's look at an example. I have 2 matrices A and B, and let's see if they are inverses of each other. So verify that B is the inverse of A. So to verify that, I need to show that A times B equals I2, because they are both 2 by 2s. And then also B times A is also I2. So it's not enough to just show that A times B equals I2. So multiplying on both sides, both ways. So let's see what is A times B. Just like when we multiply x and y, we just write xy, so I don't put anything in between. So AB will be the matrix A, which is 2, 1, 5, 3, times the matrix B, which is 3, negative 1, negative 5, and 2. And let's see what we get out. So they're both 2 by 2, so the result is going to be a 2 by 2. So it's going to be 2 times 3 plus 1 times negative 5. So 2 times 3 is 6 minus 5, that's 1. And then 2 times negative 1, that's negative 2, plus 1 times 2, that's a 0. And then 5 times 3 is 15, plus 3 times negative 5, so minus 15. So that will give me a 0 here. And then 5 times negative 1, that's 5, plus 3 times 2, which is 6. 5 times negative 1 is negative 5 plus 6, which is a 1. So this is I2. So this one checks out. Now let's check the other one. B times A. It's going to be B first, so 3, negative 1, negative 5, 2, times A, 2, 1, 5, 3. So let's see what we get. 3 times 2 is 6. Minus 5, that's 1. 3 times 1 plus negative 1 times 3, that's 0. Negative 10 plus 10, that's 0. And then negative 5 plus 6, that's 1. So that is I2 as well. So yes, B is the inverse of A. We write B equals A to the negative 1. So A to the negative 1, it does not mean 1 divided by A. We cannot divide like that. So that's not what it means. It's just a notation. If you recall, in college algebra, we denoted this with the inverse of a function, f to the negative 1. And then when we had f composed with f inverse, they undid each other. So this is something similar to that. All right. Then let's see how to find the inverse. So the example gave you the inverse and just asked you how to verify that they're inverses of each other. So if we have a 2 by 2 matrix, finding the inverse, there is this rule. So if your matrix is a 2 by 2, it's going to have 4 entries here, there, here, and there. Then the inverse, A to the negative 1, is going to be A times, it's going to be this number. You take A times D, and then you subtract B times C. That's just a number. And then multiply by this matrix. Notice that this matrix, I just switched the A and D right here. So it has D here and A here. And then instead of CB, I have negative C and negative B. So this is a rule that tells you how to find the inverse of any 2 by 2 matrix. But if you calculate this quantity, AD minus BC, and you get that it's 0, since we can't divide by 0, we say that we cannot, it does not have an inverse. So actually this number is called the determinant of A. And we will talk more about determinants in the next section. All right, so let's find the inverse of this A right here. So it's a 2 by 2. So according to the rule, the inverse of A is just going to be, let's see what's my A. What plays the role of my A? Well, A is in the first row, first column, so A is 4. B is 5. C is 2. And then D is 3. So I'm applying the rule. The rule is going to tell me that the inverse is going to be this number, which is A times D, so 4 times 3, minus B times C, 2 times 5, and then times this matrix, DB, so D is 3, A is 4, and then negative C and negative B, so negative 2 and negative 5. All right, so 1 over 12 minus 10, which is 2, and then 3 minus 2 minus 5, 4. And then if you recall from last time, multiplying a matrix by a constant, you multiply each entry in the matrix. So the answer is going to be 1/2 times 3, which is 3/2, negative 5/2, negative 2 divided by negative 2 is negative 1, and 4 divided by 2 is 2. So this is the inverse. So you can check your work, check that A times A inverse is I2, and then A inverse times A is I2 as well. If you need practice with multiplication of matrices, you should always check, and especially if it's on an exam and you have to put in the entry, you should always check so that you make sure that you have the right answers. All right, what about if we have a larger matrix? So for the 2 by 2, we have this rule that tells us exactly how to do it, but what if we have a larger matrix? So for example, if I have an n by n matrix, how do we find the inverse? Well, we're going to first construct a n by 2n matrix. So what we're saying in here, I'm going to put the matrix A on the left-hand side, and then I'm going to attach the identity matrix of size n. So I'm going to have n columns from here, and then n columns from here. So that's why it's going to have still n rows, but then this is going to have 2n columns, n from this one plus another n from that one. So we're going to work with this matrix. First, we're going to write it. So this is the matrix A that you want to find the inverse of. And then this is the identity matrix of the same size of the matrix A. We're then going to use elementary row operations on this new large matrix. So we're going to do these operations until on the left-hand side, we have the identity matrix. So this means that we are changing the large matrix to reduced row echelon form. So we're working with this, so similar to what we did last time, we're going to bring this into reduced row echelon form by doing the row operations. Then at the end, what we're going to have on the right-hand side, when we're done, that's going to be our inverse. So let's see an example. It's going to be clearer when you have an example. All right, so this is the matrix I want to find the inverse of. It's a 3 by 3, so I can't use the rule that I have for a 2 by 2. So I need to do this method. So the first thing, you're going to write the large matrix. So the large matrix is going to be your A matrix. And then I'm going to put the identity matrix of size 3 because I have a 3 by 3. So I'm going to need the identity matrix of size 3. So 1's on the diagonal and 0 everywhere else. And then I'm going to work with this one to get the reduced row echelon form. So we're going to make sure that the leading entry in first row is a 1, which it is, but then everything below it has to be a 0. So this needs to be a 0, this needs to be a 0. So let's do it. So how do I make this a 0? What multiple of row 1 added to row 2 is going to give me 0 on row 2? Well, if I take negative 2 times row 1 and add it to row 2, negative 2 plus 2, that's going to make a 0 where I want a 0. So this is how row 2 is going to change. Row 1 stays the same. I didn't do anything to row 1. So let's do that. Row 1, I'm just going to copy it. And now in row 2, negative 2 times row 1. So negative 2 times 1, that's negative 2 plus 2, that's a 0. Negative 2 times row 1. So negative 2 times negative 2, that's a positive 4, minus 3, that's a 1. Negative 2 times negative 4, that's positive 8, minus 6, that's a 2. And I'm going to do it to this matrix as well, to these 3 columns as well. So negative 2 times 1, negative 2 times row 1, so negative 2 times 1 is negative 2, negative 2 plus 0 is negative 2, negative 2 times 0 is 0, plus 1, that's a 1, negative 2 times 0 is a 0, plus a 0, that's a 0. So this is how I made this 0 into a 2. Now, let's make this negative 3 into a 0. So what multiple of row 1 do I need to add to row 3 such that negative 3 becomes a 0? Well, 3 times row 1, so 3 times 3 3 times 1 is going to be 3 plus negative 3, that's going to make a 0. So I need 3 times row 1 added to row 3 to become my new row 3. So 3 times 1 is 3 plus negative 3, that's a 0. 3 times negative 2, that's negative 6 plus a 6, that's a 0. 3 times negative 4, that's negative 12 plus 15, that's a 3. And then 3 times 1 is 3 plus a 0, that's a 3. 3 times 0 plus a 0, that's a 0. 3 times 0 plus a 1, that's a 1. So now I have zeros where I want, and then I'm moving on to the next row. The leading entry on the next row, on row 2, is already a 1, and it already has a 0 below it, but it also has to have 0 above it. So recall from last time, the row reduced echelon form has zeros above and below the leading entry. So how do I make this a 0, sorry. How do I make that a 0? Well, I'm working with row 2 now. So what multiple of row 2 added to row 1 is going to change this entry into a 0? Well, 2 times row 2 is going to do that. So now I'm going to change row 1. 2 times row 2 plus row 1 is going to become my new row 1. So 2 times 0 plus 1, that's a 1. 2 times 1, that's a 2, minus a 2, that's a 0. 2 times 2 is 4, minus 4, that's a 0. 2 times negative 2, that's a negative 4, plus a 1, that's a negative 3. 2 times a 1, that's a 2, plus a 0, that's a 2. And then 2 times 0 plus 0 is a 0. So I changed row 1, and this negative 2 became a 0. And let's copy down the rest. So row 2 stays unchanged. And row 3 as well stays unchanged. So leading entry, zeros below it. Leading entry in row 2, zeros below and above. And now I'm moving on to row 3. I need to make the leading entry. First, I need to make it a 1. And then I need to make everything above it 0. So to make it a 1, I'm just going to divide row 3 by 3. So for the next one, let's just do it here. So divided by 3, divided by 3, divided by 3. So I'm going to write it in here, 1, 0, negative 3, 2, 0, 0, 1, 2, negative 2, 1, 0, 0, 0, 3 divided by 3 became a 1, 3 divided by 3 is a 1, 0, and then 1/3. Okay, so the only thing I need to do now, I have a 1, zeros below it, 1, zeros below and above it, and then this is a 1, I need to make zeros above it. This is already a 0, so I need to make this a 0. So I'm working with row 3. What multiple of row 3 added to row 2 is going to make this a 0? Well, I need negative 2 of row 3 added to row 2. So negative 2 row 3 plus row 2 that goes into plus row 2 that goes into row 3. So row 1 stays unchanged. Row 2 stays into row 2, sorry. Row 2 is the one we're changing. So negative 2 times row 3. So negative 2 times 0 plus 0, that's a 0. Negative 2 times 0 plus a 1, that's a 1. Negative 2 times a 1, that's a negative 2, plus a 2, that's a 0. And then negative 2 times a 1 is a negative 2, plus a negative 2, that's a negative 4. And then negative 2 times a 1, oh, we did this one. Negative 2 times 0 plus 1, that's a 1. And negative 2 times a third, that's 2/3 plus a 0. And then row 3 stays the same. Let's see, is it in? So now notice that I have the row reduced echelon on the left hand side. This is actually the identity, right? So I stop when I get the identity on the left hand side. And then what I have on the right hand side, that's my A inverse. So A inverse, I found that it's -3 times 2 times 0, negative, not times, -4, 1 and 2/3, 1, 0 and 1/3. So there we are. We found the inverse. So the steps are write down the matrix and beside it write the identity matrix and then perform row operations until they switch places. The identity is in here and then you have another matrix in here. And that other matrix right there is your inverse.